here. Welcome, everybody. Thank you for logging in today to this relatively short for us webinar on introduction to the RCM and GCM data and SimCLIM 4.0 for desktop. I'll speak for about 30 minutes here and go through a few things with you. And we won't get into the software in detail, but I'll be able to show you some key aspects of it in terms of the use of GCM and RCM data. And then I'll stay on afterwards for those that like to hang on and ask some questions. We can do it through chat or through audio for those that like to talk to me about things. So let's just get started here. First of all, I want to run you through the SimCLIM program in terms of, I'm going to move this stuff all aside here. And we'll go through the various aspects of the desktop. First of all, the most important thing here is the study areas. With SimCLIM, we've developed many, many study areas for you to have access to. We have hundreds, actually. I've got a fair few loaded here. So what we do at CLIM Systems is we do provide RCM and GCM data already prepackaged into usually country areas. As you see here, I have Vanuatu, Trinidad and Tobago there for you, Shane. Albania, Zambia, Mozambique, Tajikistan. We have USA, Canada, all done by province and state as well for Canada and the USA. So we have quite a few data sets available. As I mentioned, we have GCM data, but I also want to show the latest that we've got in terms of Cordex data that's now available within SimCLIM. So what we have done over the last 4 or 5 months is collect all the Cordex data that has been put out by various groups around the world, and we have post-processed all that data to make it available within SimCLIM. So we have the North American that just came online a couple of months ago, actually, the North American domain, Central America, South America, Africa, Asia, Europe, South Asia, recently Australia, New Zealand, and South Pacific, where we are located, just came online, East Asia. As you see here, there are various numbers of variables that are produced by these Cordex groups. So we have processed 22 patterns for Africa. So for all the African countries that we generate data for, we have 40 GCMs plus 22 RCMs that we can provide data for. So it's quite a comprehensive look, and this is the domain for the African Cordex group, what they have data for. And as you see, for MENA, for Middle East and North Africa, there are only 5 Cordex models. But again, there's overlap for much of North Africa. So again, we can produce those patterns, so you get the 22 plus the 5 plus the 40 to have quite a few patterns that you can be looking at. And as I show here, for Central America, we again have processed 10 RCMs for Central America. And for South Asia, there's 7. And for South America, just 2 at the moment. But we keep monitoring this. More RCMs come online all the time. We have the Arctic covered now, with 7 RCMs done for the very important Arctic area with a full 7 variables. Excellent coverage for the Arctic. And we also have East Asia covered with 6 models at present. And also North America, as I said, only 4 variables available. But we have a full 16 models for North America. So with these 4 variables, this is a minimum, mean, and maximum temperature and precipitation. And that covers Canada as well. Most of Canada, not all of Alaska, but a fair bit of Canada as well is covered by that North American domain. And then Australia, our part of the world, Australia, New Zealand, Indonesia, Malaysia, and Southwest Pacific is covered by the Australians to put these out, and just recently. So there's 6 in this case for that region. Then we have the European domain, again, quite a good one with 7 variables in most cases. So 7 variables, as I say, in most cases, except for 1. Again, very good coverage for Europe. And that's all available now as part of the SimCLIM package. So you don't just get statistically downscaled GCM data available now. We have very comprehensive RCM data built into the system as well. So this covers off what people are talking about. We need to see statistical and dynamically downscaled data. When we're doing our assessments now, both are very much available within the SimCLIM system. So we're quite happy to have all that there now. Further descriptions of all this is available within the desktop data manual. So we have a very comprehensive description available of how all this data is put together and the descriptions of all of it. So for those technically inclined who need to learn about this, you can have a look at the SimCLIM data manual. And before I get into the program itself, there is, again, a comprehensive desktop essentials manual that covers all the aspects of the software. It's 192 pages, very comprehensive, how everything's put together, how ensembles work, what the basis for the ensembles. There's not only the technical use of the software described here, but the application of the software. So it's quite a detailed user guide for doing everything that I can't have time to go through everything today, but this is readily available on our website. So for those of you that want more information. All right, in terms of the program itself and how it uses that RCM and GCM data. You can open up USA mainland here. Now, I'm going to run across the toolbar, just give you a feel for what is available here within the SimCLIM desktop program. The key areas that we look at, there is a global projection database. It's a very quick access to things about the different RCPs for temperature, just do of all IPCC related data on sea level rise, CO2 concentration, and so on, easily pulled up here just for reference. If you need to know what the RCP 8.5 and the high sensitivity CO2 concentrations are projected to be, that's all easily accessible here. And then one of the key aspects is a scenario generator. This is where we get to make maps of the particular areas for baseline and for future scenarios. Now, again, we do follow IPCC guidelines in terms of how we've put the science together for SimCLIM. So you can easily create ensembles by clicking on as many of the models as you wished. Or just 1 or 2 models. It's 3 models, 4 models. It's up to you how many you want to select. So it's very powerful in terms of being able to create ensembles depending on what you require. Also for creating the baseline climate. Of course, the RCPs are all there, all 4 RCPs. You can create, do some analysis by picking a 10 and 90 percentile if you'd like to produce 3 maps showing the variability across the models. And of course, climate sensitivity is there as well. This is about the feedback mechanisms, again, described in the IPCC guidelines and by the IPCC and within the user manual. Again, you get to choose either for a whole year. You can choose wet and dry seasons, depending on the part of the world where you're working. You can pick winter, spring, summer, fall season, whatever you want to choose in terms of months. There's a batch mode capacity here, so if you want to run various scenarios and just run RCP 2.6 and so on. You want to run all four of them, but you only want to choose to do this once in terms of setting it up. You can use the batch mode. There's lots of flexibility here. All right, so that's with this GCMs and RCMs are all available within the program here to choose from. So you can compare RCMs against the GCMs if you wish. You can mix them together. That's all possible within the scenario generator. Let's go back and just very, very quickly produce a baseline scenario just so you can see what the map looks like here. And then you can create another scenario and overlay. All these tools come to life, so you can synchronize the legends, you can compare, you can change the palette, all these sorts of things. These are all exportable into ArcGIS, all kinds of things like that. We don't have time to get into too much detail about this now, but it's all described in the user manual and also on YouTube videos that we have posted. All right, so that's the introduction, very quick introduction to the scenario generator. We're working on a beta version of that as well, the map generator, that's going to have quite a bit more functionality in terms of access to shapefiles. That's just under development, but that'll be released in the next few weeks. Very powerful new map generator. The other very powerful tool here for looking at the models is the site-specific scenario generator. We find this to be very useful for people. We can look at all the GCMs. I'm going to run through this one just because I think this is very useful for people to understand all the models that are available. And let's just look at 8.5 and apply that. And they're very focused on visualization here and being able to see what the data is within the system, within the GCMs, be able to compare GCMs, because many people have, over the 20 years we've been doing this, have been always asking for transparency, the real values in the GCMs. So that's processing all those GCMs to the U.S. mainland. In this case, they're 39. This is pre-SIS derived data for the U.S. We worked with doing VCSE for the U.S. So this particular data set that's been generated for the U.S. situation in particular, that's in line with U.S. requirements. And then once that pops up with map, we can just choose any place. I'm just going to do one randomly here. And you can load the data. And you can chart, in particular, the maximum temperature range for that particular place in that map. But more interestingly, we need to look at the GCM. It's powerful for people. It's happening within the models. So you can actually, within SimCLIM, look at each individual GCM for each month and see how it is displaying per degree of global warming, the change for that particular place. And you can look at the 10th and 90th percentile. You can change this if you want to look at 25 and 75th and the medians there across the GCMs by month. But even more exciting is this chart that you can look at. You can see where the GCMs all fit together, where the outliers are, which GCMs don't fit as closely into the mean, that's their median that runs through. And how tightly they are packed. So you can see the confidence across GCMs as well, month by month, how they fit together. This is quite a powerful way of understanding the range of values across GCMs. And then you can pick out the ones that are outliers there and think, what's going on there? And you can then remove those if you wish, or you can leave them in and see how the ensemble changes the values with outliers left in. There are many things you can do once you can identify these GCMs. And again, it's all about transparency here, that you can see what the GCM values are that are going into the modeling. It's a very powerful tool, this charting. And there's much more we can show you on this, but we don't have time this morning, but there's plenty to do with this sort of tool. Very powerful. So again, this is the site-specific scenario generator, and again, across all the variables, temperature, precipitation, wind, all kinds of variables are available depending on where one is working in the world. The other powerful tool is the site-specific sea level rise scenario generator. Again, this is the only tool of its type we're available that we know of that has all the GCM data, includes vertical land movement within the analysis, where you can do a very rapid assessment, again, an ensemble of patterns for sea level rise. And again, you can do percentiles, so statistical analysis can be done there, choosing the RCP of your choice, then apply, and working with 28 GCMs for sea level rise. This will generate a map again where you can go to any coastline around the world and choose. Let me zoom in on this. So we can go to the Gulf Coast, which is usually an exciting area. And I'll select place down in the Mississippi Delta, for example, and load the data and chart. And there you go. There you get your sea level rise scenario generator. Now, I haven't put in vertical land movement at this point. There's a bit of a process to doing that. It doesn't take that long, but I don't have time to show you right now. But once you add the vertical land movement component in that, this will shoot up to about nearly 2 meters, actually, by 2100 for the Gulf Coast, because, of course, there's subsidence there. So that's an important aspect as well in the site-specific scenario, or sea level rise scenario generator. Again, very rapid explanation of it here, but there's a lot more details in here where you can look, you can save, you can copy this data out, you can look across each year of what the sea level will be, low, medium, and high scenario sensitivity. Quite a powerful tool for assessing sea level rise any coastline around the world. This gets used quite a bit by people using SimCLIM. They really enjoy this functionality, especially because it includes the vertical land movement component, which is really quite critical. In some areas, there's quite a bit of subsidence. In other areas, in the Arctic and such, there's the uplift, of course, from isostatic readjustment. So we have all the tools for sorting out that vertical land movement, and they're easily accessible. But I'm not going to show that right now. You can look at a YouTube movie we have online to see that. All right, other tools here that are very important. You have a scenario set generator where you can run hundreds, literally hundreds of scenarios at one time. The other really critical tools are site-specific. And this is very important to have historic time series data that you can work with. So we have a data browser. I don't have the U.S. site data loaded right now. This is, again, pre-sys data. We have for the U.S. thousands and thousands of sites preloaded within SimCLIM. You're getting a glimpse of how many thousands we have from Environment Canada. They're already can come preloaded in the system if you're interested in Canada. We have the BOM data from Australia. We have all kinds of site data to load for you depending on the country you're working in. And with all this, there are all these tools available to apply to that data as well. So if I just load some random data here, all these tools come to life. So you can see, you can do long-term normals, sums, sort the data, look at running means, and all these sorts of activities that you can do with this data. You can also run scenarios on that data. Very important. Now, one of the critical tools in this is our extreme analysis tool. This is used based on the historical time series data that's loaded here. You can choose Tmax, Tmin, precip, and so on. Precipitation is a very critical aspect. I'll do a very quick one. And there are tens. Oh, that's not in that site. Let's see if there's any data here for sea level, for precipitation. Select all. And precip, there seems to be some data there. So we can run that. And very quickly, you have an extreme event analysis for rainfall, 77 millimeters with a return period of 29 years. One of the return period of 1 in a 100-year event, that's 94 millimeters for this part in southern Ontario. We can then run, let me close it, move this aside. We can then look at a scenario. We use daily GCM GEV values. Again, this is quite a unique tool. We developed this because of problems with monthly data that doesn't show the changes in extremes. For example, we have places in the world where environments over an annual basis are getting drier, but on a daily extremes are getting worse. So we have to be able to tease that out. We go 2050, and let's just select a few so it runs quicker. This will save us some time. And we run RCP 8.5 medium and run this. And we can look at how the extreme event rainfall is going to change. And again, we can apply this anywhere in the world. And we see that the extreme rainfall then with an RCP of 8.5, 1 in a 100-year event, is looking at 109 millimeters versus what we had for baseline, which was 94. So slightly wetter extreme events expected in this part of southern Ontario in the future. Again, you can run these scenarios with different RCPs, a 4.5, 6.0, and so on. So very powerful in terms of a rapid assessment, but scientifically robust of extreme precipitation values. We can also do temperature, and it's very important. You can look at maximum temperatures. You can set a threshold of, say, 30 degrees Celsius and see how that will change in the future in the return period on a 30-degree day. You can also look at multiple days, so you can look at heat waves. What is the return period for 4 consecutive days over 35 degrees Celsius? Again, you can look at the YouTube movies online to see how to do that in detail. And again, the manuals go into great detail of how to do this sort of analysis. Okay, the other aspects of the tool that are here, of course, you can run impact models. We have various impact models built into the system. A rainwater tank model, a degree day model is available here, and a Bruin Rule shoreline retreat model is here, very easily accessed. The other things that we work with and perturb data for on the fly here are DHI models. So Danish Hydraulic Institute models running on DFS-O files are easily perturbed here, and then you can run those files through Mike 11 and so on to see about how climate change impacts flooding. We also have a link with the Decision Support System for Agro-Technology Transfer, one of the premier agricultural modeling systems of the world, designed with Garrett Hogenboom and his team. We again have a perturbation tool here to run that, and we can also perturb input data for swap model, all on the fly here. And we're always open to hear about other models that people need perturbed data to run. So in fact, you can run these models with climate change data. These are all management tools, managing areas, managing sites. You can import, export. Everything is GIS compatible, ArcGIS compatible, linked with Excel. All these sort of things are very easily done. Impact models are brought in, shape files, change the palettes. All these sorts of things are available, and including a calculator for looking at maps and comparing maps. All right, that was my 30 minutes of a quick run through of SimCLIM and the data and how it gets applied. Underlying this is GCM and RCM data, readily available for the world. We have country-level data sets, I think 204 countries now built. We can do customized areas. We work in watersheds. We work with the Mekong River Commission and have generated models just for the Mekong River. The Nile, we work with the Nile Basin as well group, and they again just wanted models for the Nile Basin. So all these things can be done. We do customized cities as well. We've done Ho Chi Minh City, Beijing, Melbourne, a number of cities as customized areas, again at high resolution. Typically 1K resolution is what we work to, but we've recently developed some models for the Cook Islands and atolls at 30 meters resolution because the atolls are so small. So we really can generate some high resolution models using the RCM and GCM data where it is available. All right, going to sign off until the next webinar. Thank you for attending, folks.